Hello friends, welcome to the lecture series on digital communication. We are going to engage the contents for the subject ETL 305 Digital Communication. Myself, Anushka Kadage, is going to engage the sessions on this particular. In this particular course, we are going to see first of all the chapter which is including the different digital modulation schemes named as pulse code modulation, adaptive pulse code modulation, adaptive differential pulse code modulation, delta modulation, adaptive differential delta modulation, and CVST. As a second unit, we are having the definition of information, equation for entropy, information, the source coding theorems. Then we are going to look for the channel coding theorems, including the Shannon's theorem and Shannon-Hartley theorem. While this chapter is again including the numericals and the procedure for getting the source coding to be done by the method of Hoffman's coding and Shannon-Fano coding. As a third unit, we are going to see what are the basic requirement of a signal for doing transmission of that. Then what is the likelihood detection, the types of receiver like correlation receiver, matched filter receiver, their mathematical approach for getting the less probability of error, and finally in this chapter the I pattern, intersymbol interference, and different types of synchronization methods, as well as carrier recovery and symbol timing recovery methods we are going to cover out. As a next chapter, we are having the passband digital data transmission, in which we are going to cover different passband modulation methods, which are also known to be digital carrier modulation method. In this, namely, we are going to cover the probability of error equation calculations for amplitude shift keying, phase shift keying, frequency shift keying, and M-array signaling for all these different types of shift keying methods. As a next unit, we are having the content of spread spectrum technique, wherein we are going to see the CDMA application of direct sequence spread spectrum technique, then frequency hopping spread spectrum technique and its applications. And as a final unit, we are going to see for different coding techniques which are utilized for either detection and then correction of the transmitted data, and in that transmitted data whether any error has happened or not, that will be checked out and corrected also. So friends, with this all introduction, now we are moving towards the actual contents of our syllabus. To start with the contents with our learning outcomes of how the analog and digital signals will be defined, the basic difference between the features of analog and digital signals, different blocks involved in the basic communication system and modified digital communication system, and finally we are going to state the advantages for the digital communication process. So here friends, we are starting with the definition of communication. So communication is nothing but sending a signal over some medium from one sender to the receiver. And here we are getting the signal to be transmitted from a sender to the receiver by using some transmission medium. But in reality, when we are transmitting any signal, we have to look for the actual bandwidth of the signal to be transmitted and the bandwidth of the channel over which we are transmitting the signal. So this is a physical situation of the number of instruments and the channel which is present. So let's say that the bandwidth of the transmitted signal is more as compared to the bandwidth of the channel. So when such like signal will be transmitted on the channel, then you can see in this diagram of the received signal that the major portion of the information has got lost. That means here when this transmitted signal was loaded on the channel, this was got corrupted, and because of that information loss has happened. And this is what the case that we have to understand when we are going for the digital communication process. So what is the requirement for the communication process? How to get the more amount of data to be retrieved at the other end, and if any error has occurred, how to get the retrieval of that particular error. And for that, first we have to understand the major features of the analog and digital signal. But before that, we will define the analog signal and the digital signal. So analog signal is a signal which is showing continuous level changes with respect to time. So in the analog time domain signal, we are going to find out multiple number of levels which are present. While in the digital signal, either only two discrete levels will be present or the defined number of discrete levels will be present. So in the following diagram you can see here is one level which is present, may be said as high level, and this will be termed as a low level. But in forthcoming part of this signal we can observe this as a low level, this as one another level, this is as a third level, then this will be again as a fourth level. So here four number of discrete levels are present into this signal. So digital signal will be present with finite number of discrete levels present into that. But generally the digital signal should be termed as a binary signal itself, where the two voltages or two levels will be represented. So the overall scenario for communication process will be having the representation of an input signal which is in analog in nature. That means overall information is present in analog signal form. That data or information may be of type text, voice or picture. Once this information is available, by using the encoder, we have to get that converted to digital information, or the discrete number of states are to be obtained from this infinite number of levels which are present at the input. So as far as the analog signal has concerned, we have said that it is showing the continuous variation in the amplitude levels with respect to time. So its form of presentation may be a sinusoidal signal, and the features which are looked for any analog signal will be frequency, amplitude and phase. Now in this case, the frequency will be nothing but the number of repetitions that those are going to happen over a complete one period, that is called to be frequency, while amplitude is nothing but the difference of the extreme points of that signal on positive side and on negative side with respect to the midpoint of that cycle. Similarly, now the phase we are going to define as it is the angular position change of the wave with respect to time. In the same way, we will now look for the different features for the digital signals. As mentioned earlier, here in digital signal, the number of levels will be discrete and they will be finite in number. Generally, we are referring only two levels, that is 0 level and 1 level. So those signals may be said to be binary digital signals, and that's why the unit for information representation of digital signal is bit. And the